Hello everyone, I'm Hao, a PhD candidate at the Norwegian University of Science and Technology. In this video, I'll be giving a quick overview of my PhD work in the Annulight program, a European Commission funded project under the Marie Curie Actions. In the aviation industry, an important aspect in the certification of plane airworthiness is the ability to restart or reignite the engine mid-flight when a flameout occurs. To design better engines that can safely reignite at high altitudes under freezing ambient temperatures, it helps in understanding the flameout and ignition phenomenon. And that's my main PhD research, to study the critical process of engine ignition and flameout. With the innovative training network provided under the Annulight program, I've participated in collaborative training and research with companies such as Safran Helicopter Engines, and academic partners such as Cevex, Cambridge University, and TU Munich, so that we may gain a better understanding on engine ignition behavior and help enhance aviation safety. Research on lowering greenhouse emission during the engine ignition phase is also conducted to promote a cleaner environment for a better future. Right now, we are in the NTNU combustion lab. And in NTNU, we study the ignition and flame blow-off in a controlled environment, using various diagnostics on different setups. In an aircraft, there will be an engine component that resembles this very simplistic combustor setup we have built over here. In particular, two different configurations of a laboratory combustor are used for my study. One is an annular combustor with a simple injector design so that we may seek a better theoretical understanding of the physics involved in ignition. And the other one is a much more complex design, which seeks to replicate realistic engine conditions. This is designed in collaboration with Safran Helicopter Engines to mimic the new spinning flame concept in the new generation of Safran Ahano engine. This new spinning combustor design confers a huge bulk swirl that propels the flame in a single dominant direction, with a much faster light around time. As we can see from the ignition video, during the process of light around, which is basically flame propagation around an annulus chamber, the Safran test bed on the right ignites much faster than the typical combustor on the left. The flame propagation direction is also more deterministic with only a single flame branch, compared to two opposing flame branches as seen on the left. This suggests some of the advantages of the new spinning engine design concept. Further work is being performed to investigate the performance of this engine design under lean operating conditions, which is basically running the engine with minimal fuel. And it's hoped that all these studies will help contribute to a cleaner and safer aviation industry.